So this is video 19 for day 19. So this is going to be the Thursday of week 4. Okay. So yesterday we talked about the idea of a hash table and how we could use separate chaining, which basically is in each bucket of our hash table, we put a linked list so we can just add things to it, take things away, whatever, and it should be fine. So what we're doing today is linear probing. There's also quadratic probing and double hashing. And all those are ways to avoid using a linked list. So you may think it's easier, and in some ways it is. You don't have all the pointers and all the linked list stuff. But at the same time, it means that if you have a hash table of 100, then 100's all you're going to store. 100 items, or it's it. So the hash table size becomes more important. Okay. So the tutorial is pretty in depth this time and going into the different ways to do it. The simplest approach is just the linear probing. And the idea there is that and we've got an example here. So we've got our function here. It's a 10, 0 to 9, so size of 10 for our hash table. We try to put it at 72, it goes into position 2, life's good. Okay. Put at 27, it goes to 7, no problem. 36 goes to 6, no problem. Okay. 24 goes to 4, no problem. And then 63 goes to 3, no problem. Okay. When we try to put in a 47, okay, um, the hash key returns, or the hash function returns the key of 7. You go to here, but it can't be there. Okay. There's already a 27 there. Okay. So instead, we're going to push it one forward. We're going to push it to 8. Okay. If we had to, we could push it further. Okay. We're going to push it to 8. That means now if I go to search for 47, I'm going to look here at the 7. If it's not here, then I'm going to keep moving until I find it. How will I know that I'm done? When I hit a blank cell. Okay. So it gives us the problem in general. If I wanted to search for, let's say, 102, it's going to take me here. I would have to also search here and here, although they have nothing to do with the two. And only when I get here would there be an issue. Okay. Would I know that it's not there? So this adds some problems for sure. Okay. And it's just going to keep doing that with the linear. Okay. So the linear basically is going to increase it by 1 every time. Okay. The quadratic, on the other hand, is going to try to spread things out more by doing a squared function. So the first time you move it by 1, then by 2, then by 4, and then by 16 and so forth. And that's a way to spread out the data more, okay? To avoid the concentrations and the clustering, okay? And then the third one, it's harder to explain in a quick video overview, but on the third one, on the double hashing, you basically are going to keep track of two different scales that you're hashing to. Okay. You'll pick a number to use for the second part, and it's a way to randomize things even further. Okay. So definitely worth reading through those chapters pretty carefully to make sure that that you're understanding what's happening. Okay. So that's all important stuff there. Okay. So the linear probing can lead to primary clustering. The quadratic can lead to secondary clustering, but the double hashing can eliminate both of those. Okay. So in general, the open addressing works best if your load factor, and I said lambda before, it's actually an alpha. I just couldn't see the writing on that. We usually say alpha for that. As long as the alpha is less than 0.5, which means you're less than half full, then the open addressing may be fine. Okay. Um, as part of the Lab 19 assignment, it's going to have you calculate some examples and see exactly where performance starts to fall apart. Okay. The other thing to think about in all of this is that when we go to delete something, it's not quite as simple as we would like it to be. Okay. In that. So let's look at an example here that we have. So let's say that we're um, at even this version of our, I'll highlight that maybe. So let's say we're here, okay? Or this one. Okay, so we've got 72, we've got 63, we've got a 24 there, we've got a 36, we've got a 47. Okay. So let's say to further make this example be what I want it to be, that we've got a 72, 82, 92. They're all here together. Okay. So if you do a 92, it's going to start here, search there, and search there. Okay. If you want to delete the 82, okay, you can't just delete it, or then it would never make it to the 92. Okay. So instead, we have to do what's sometimes called put a tombstone there to let it know that something was there before. Okay. So basically now there's going to be states that we can have, and we can do an enumeration for this. Okay. So enumeration is a variable that you create that can have only distinct values. So in this case, the slot state can be either empty, there's never been anything there, occupied, there's something in it, or deleted. There was something there, so now that it's gone. Okay, so when you're moving to keep searching for what you're looking for, when you can't find it, you keep go to the right, to the right, to the right. Instead of just stopping the first time there's an empty slot, okay, you would, when you see a deleted slot, you keep moving because you know there may be more of that particular bucket to the right. Okay. So that's kind of how that works. Okay. So during the search, you're going to treat the deleted as occupied and keep going, basically, is what that means. Okay. But during the insert, so when you're inserting a new one, the deleted are available, so you can reuse the slot. Okay. So adding that deleted category is important to keep holes from happening inside of that. Okay. So that is kind of what we have on that. So again, that you'll have some skeleton code for tutorial 19 as usual, and you'll be able to go through and test some stuff out. Okay. So portfolio is on the hash table ADT. Okay. There are starter files that are there for us to work with, and you can choose either separate chaining or open addressing, either one, or implement both if you want to be wild and crazy about it. Okay. Then the reflection, you have to address whatever collision resolution choice you made and your load factor decision. Okay. With data from the labs that you did in 19, lab 19 and lab 18 and lab 19. Okay. That'll be your evidence. Okay. So tomorrow we'll talk about sorting algorithms a little bit. And then next week, our last week of class, we'll go on to talk about graphs. Okay. So this is a shorter video, I hope. Again, the bulk of the work we did was yesterday talking about the hash tables. Hopefully this will be a lot more straightforward. Okay. If you have questions, as always, make sure that you let me know.